I wanted to find out how a pendulum oscillates in vacuum. This is how I did it. A small rubber ball is suspended to a wooden frame with the help of a thread. Pendulum oscillates when released. It slows down after some time. Its mechanical energy is gradually lost due to frictional forces, mainly air resistance. Its amplitude, which is the maximum distance from the equilibrium position, continuously decreases. This is also known as damping. What if less air is present? Will it result in less damping? To trigger oscillations inside the vacuum chamber, we will take help of this release mechanism. Ring magnets are placed inside the syringe casing. Movement of the ring magnet is triggered with the help of another set of strong magnets externally. This results in tilting of the syringe and pendulum ball is released. Let us watch it in slow motion. I visited the Center for Science Education and Communication at Pune University for the same. We will place a pendulum unit inside a vacuum chamber. This vacuum chamber can create a partial vacuum, which is good for our basic setup. Pressure inside the vacuum chamber is measured in millibars. Right now, it is 0.4 millibar. Let us analyze if there is any reduction in damping when the pendulum is placed inside a vacuum chamber. We will compare two instances here. Upper one is inside the vacuum chamber with 0.4 millibar pressure, while the lower one is outside the chamber at standard atmospheric pressure. Our standard atmospheric pressure is approximately 1013 millibars. Let us mark the amplitude when the pendulum is initially triggered at its max position. Red line for the upper one while blue line for the lower one. With the passage of time, amplitude decreases as a result of frictional forces. We will mark the amplitude again after 45 seconds. Less damping is seen when the pendulum is inside the vacuum chamber. There is very little air inside which offers resistance to the movement of the pendulum. I also wanted to explore how a pendulum will behave inside water. Pendulum unit is placed inside an aquarium tank. Thick stone slab ensures that the wooden assembly stays inside water. Pendulum could barely complete half oscillation before coming to a complete halt. It also moved sideways as it neared the center. This may be due to the turbulence caused by my hand movement inside the water. I am not very sure though. Water offered a very high resistance to its movement as compared to the normal air. Actually, I wanted to time the oscillations in the vacuum chamber for a longer duration. But after 2 minutes, pendulum started swinging randomly. This could be attributed to various factors like vibrations caused by the pump, leveling issues, jerk during the release, and so on. I am planning to do this activity again with a modified release mechanism. I should also be able to conduct multiple runs inside the vacuum chamber itself. Thank you.